So, good evening, everyone. This is lecture number 4 after a long time. And in this lecture, we are going to do something known as a very small topic, total internal reflection. Now, before going on to internal reflection, let's have a quick recap of what we had discussed so far. In refraction, we were dealing with refraction at plane surfaces, yes or no? We had seen what happens with refraction at plane surfaces. I'll just give you a small summary of what we have done so that we all come. We had seen what do you mean by refraction, yes or no? Refraction is the bending of light rays as it travels from one medium to the other medium. A denser medium is a medium where the speed of light is slow. A rarer medium is a medium where the speed of light is fast. Yes or no? We understand this? So, when light goes from denser medium to rarer medium, and that is what is important in today's class, when it goes from denser medium to rarer medium, it will bend away from the normal. We have seen this, yes or no? From denser medium to the rarer medium, if it goes, it bends away from the normal. If it goes from rarer medium to denser medium, it always bends towards the normal. Yes or no?
Yes, sir.
Okay. So that is what our concern is right now. We had also seen Snell's law. And if you just remember Snell's law, mu into sine I is equal to mu into sine I is a constant. Remember that? Mu into sine I is a constant. Then we had seen refraction at plane surfaces. We had seen a glass slab. We had seen that the ray does not get deviated, it gets shifted. The formula is right now on your screen. I hope you are making notes, yes or no?
Yes, sir.
Then we had seen that if we have a glass slab and we watch the object from the other side, the object will appear shifted. It is shifted in the direction of light rays. That is known as normal shift. T into 1 minus 1 by mu. Remember this formula, bacha? This one, T into 1 minus 1 by mu. 1 minus 1 by mu.
Yes, sir.
Yes, sir.
Okay. Then we had seen what do you mean by real depth and apparent depth. When some object is in water and you are watching it from air, it will appear lifted up. Real depth and apparent depth. We have seen the formula for real depth and apparent depth, and that was the last topic that we discussed. Now, to begin today's class, we are going to discuss a topic known as total internal reflection. Now, what do you mean by this total internal reflection? Let us go back as what we did in the first class. In the first class, we had seen that when light moves from rarer medium to denser medium, from denser medium to rarer medium, it will bend away from the normal. Do you see this? This is a denser
Yes, sir.
medium. This is a rarer medium. The light will bend away from the normal. And by Snell's law, we also know that mu into sine I is a constant. Now, when light moves from denser to rarer medium, it bends away from the normal. I ask you a question, what happens if I increase the angle of incidence? If I keep on increasing the angle of incidence in the denser medium, what happens to the angle of refraction? Does it increase or does it decrease or does it remain same? Very simple question. I have an angle of incidence in the first medium, the denser medium, and I have an angle of refraction in the second medium, which is the rarer medium. The light has bent away from the normal. If I increase the angle of incidence, what happens? if angle of incidence is increased, the angle of refraction also increases. Do we understand this? Because mu into sin I is constant. If I increases, sin I increases, mu is a constant. Therefore, sin R has to increase. That means R has to increase. So, when the angle of incidence in the denser medium increases, the angle of refraction in the rarer medium will also increase. Do we understand this? Yes or no?
Yes, sir.
I keep on increasing the angle of incidence. I keep on increasing the angle of incidence. What do you think will happen? If I keep on increasing the angle of incidence, at one point, the angle of refraction, as you can see here, the angle of refraction would become 90 degrees because it will keep on increasing. Yes or no?
Yes, sir, it will increase.
It will increase, and at some point, this angle of refraction in the rarer medium would become 90 degrees. This angle of incidence is known as critical angle. What is critical angle? Critical angle. Critical angle is the angle of incidence in the denser medium for which angle of refraction R becomes equal to 90 degrees. This critical angle is denoted by capital C. If I say that the refractive index of this medium is mu and outside is air, what is the refractive index of air? What is the refractive index of air, beta?
Sir, it should be 1 refractive index of air.
Refractive index of air is 1. Yes, very good. So, if the refractive index of medium is mu and refractive index of air is 1, I can find out the critical angle. I can find out the critical angle using this information. How can I find it out? It gives you 1 minute to think about it. At critical angle, I have to find out the refractive index of the medium is mu and refractive index of air is 1. Angle of refraction is 90 degrees. Angle of incidence is critical angle. Can you find out the value of critical angle from here? 1 minute, think about it. Yes, can you tell me, bacha? How can I find it? I can apply Snell's law. I can apply Snell's law. The refractive index of this medium is mu and the angle is critical angle. So I can write sine of I multiplied by mu, and this I is nothing but C, yes or no? So I can write sine of C multiplied by mu will be equal to refractive index of air is 1. That will be equal to 1 multiplied by the angle of refraction is 90
Sine 90.
multiplied by sine 90. Well done, bacha. So I can write sine of C is equal to 1 by mu. Do we understand this?
Yes, sir.
Or I can write it in a reverse way. What would be the reverse way? Mu of this medium will be equal to 1 by sine C. Do we understand this? Mu will be equal to 1 by sine C. Here, mu is the refractive index of the medium, and this critical angle is the critical angle between air and the medium. Do we understand this, my dear friends? Raise hands will give me more confidence.
Yes, sir.
Okay, now in some cases, instead of air being outside, the other medium being air, it could be a different medium. So now I would request you the third diagram. If I call this medium, since it's a denser medium, I will call it mu D. The other medium is not air. Let me call it as mu R. Remember, this refractive index, and we will note it down, it depends on the two mediums that are there. If the medium is air, one medium is air, the other medium is water, the critical angle is different. If one medium is water and the other medium is glass, or other medium is alcohol, or other medium is something else, critical angle changes. So now I have two mediums. One has a refractive index of mu D because it is a denser medium. The other medium has a refractive index of mu R. Can you find out the relation between mu D, mu R, and critical angle? I'll give you a minute. If you can tell me the answer, I would be pretty happy. Yes. What is the relation between mu R, mu D, and C? How will I find it out? I will again apply Snell's law. What will be the Snell's law in this case? Tell me, fatafat. Yes? We don't know? I just applied it.
Sir, can I say?
Yes, sir, beta.
Sir, so Snell's law should be mu.
Mu,
It should be mu d, I think.
mu d,
Mu d sine c.
sine of angle of incidence, which is C, should be equal to
Mu r multiplied by sine 90.
mu r multiplied by sine of 90. Do we understand this? Do we understand this, bacha?
Yes, sir.
Class, do we understand this?
Yes, sir.
So from here I can write the value of sine C as mu r divided by mu t. Mu r divided by mu t. Do we understand this now?
Yes, sir.
Mu d is greater
Yes,
than
sir.
mu r. So mu r by mu d will be less than 1. That thing will be equal to sine of C. I'll give you 1 minute to note this down. Have you noted it down, beta?
Yes, sir.
Then we move on and see on what all factors does the critical angle depends on. Number 1, it depends on the two mediums. For different mediums, the critical angle would be different. For example, between water and air, between glass and air, between glass and water, critical angle would be different. Do we understand this? Yes or no?
Yes,
Yes,
sir.
sir.
Pakka? Then
Yes.
critical angle between glass and air or anything between air, critical angle sine of C is inversely proportional to u mu. Yes or no? So if mu is high, critical angle would be less. Do we understand this?
Yes, sir.
Raise hands will give me more confidence that we are on the same page.
Yes, sir.
Okay. The next point is critical angle depends on color, or I should say not of, should be or, color or wavelength of light. Critical angle depends on the color or wavelength of light. We have seen that mu depends on the wavelength. Mu is inversely proportional to wavelength. and it is also inversely proportional to sine of C. We have just seen that. Yes or no? So I can write.
Yes, sir.
So I can write critical angle is directly proportional to lambda. If the wavelength of light is more, critical angle would be more. Do we understand this, my dear friends?
Yes, sir.
For example, lambda of red light is greater than lambda of violet light. Now, these type of questions have come many times in your NEET exam. We know that wavelength of red light is more than the wavelength of violet light. What can you say about the critical angles, my dear friend? Whose critical angle will be more? Whether it will be more for red light or will it be more for the violet light?
So violets will be more.
Think again.
Sir, red.
So
Red
red
light.
will be more. Yes, sir.
Critical angle for red light will be greater than critical angle for violet. Remember these small things. These small things will make a lot of difference in your eventual answers. Yes or no? No, yes.
Yes, sir.
Now I can write this thing in a different way as well. If the other medium is not air, the other medium is if the other medium is some other medium, I can write the critical angle sine C will be equal to mu R by mu D. We have already seen this. Yes or no, my dear friends?
Yes, sir.
And now we have seen that we can write this because it is directly proportional. Mu is inversely proportional to lambda. I can write it as lambda of the denser medium, lambda in the denser medium divided by lambda in the rarer medium, because mu is inversely proportional to lambda. Yes or no?
Yes, sir.
And this lambda wavelength is directly proportional to the speed. V is equal to f lambda, more v, more lambda. So I can write it will be velocity of the light in the denser medium to the rarer medium. Do we understand this?
Understood, sir.
All these are potential questions that can come in your examination hall, bacha. So please note them down. I call these questions as information-based questions. You know it, you get +4. Don't know it, you get -5. You say, sir, how -5? Well, +4 if you would have got it correct. And if you get it wrong, it is -1. So effectively it is -5. Yes or no?
Yes, sir.
Yes, sir.
Critical angle also depends on the temperature. Information-based question. When temperature T increases, refractive index decreases, and therefore the critical angle increases. Again, one information-based thing that if you know, then you know. If you don't know, then you don't know. It's as simple as that, my dear friends. Have you noted it down, bacha?
Yes, sir.
Okay, this was about critical angle. But if you understand, if you remember, the heading of the class was total internal reflection. But we have lost that entire topic in our discussion. What is total internal reflection then? What is total internal reflection? That entire topic has gone in the air. We were discussing those topics, but we have lost it. So what we were discussing was very simple, that when light goes from denser medium to rarer medium, it will bend away from the normal. It bends away, right? Now, once I increase the angle of incidence, at some point the angle of refraction becomes 90 degrees. That angle of incidence is known as critical angle. We understand this? Yes or no?
Yes, sir.
What happens if the angle of incidence is further increased? So now I make the angle of incidence more than the critical angle. Then what do you think will happen? Then what do you think will happen? If the angle of incidence is made more than the critical angle, then my dear friends, what do you think will happen? Angle of refraction cannot become more than 90 degrees. So now what will happen is light will not pass into the other medium. It will turn back in the same medium, and this phenomena is known as TIR. What is the short form of TIR? What is the full form of TIR?
So
Total internal reflection.
Total internal reflection. So what do I write? If the angle of incidence I is greater than critical angle, light does not refract from which medium to which medium, my dear friends?
Denser to rarer.
Remember it. Don't forget it. If I is greater than critical angle, light does not refract from denser to rarer, but it is reflected back. But it is reflected back in the same medium. And this phenomenon is known as
TIR, total internal reflection.
yes, my dear friends, TIR, total internal reflection. I'll give you 1 minute to note it down. Have you noted it down, my dear friends?
Yes, sir.
Then we will write conditions for TIR. Conditions for TIR. There are two conditions which are necessary for TIR. Yes. Condition number one. Tell me. Condition number one for TIR. First condition.
Angle should be more, sir. Critical angle.
Think before that.
Critical angle should be more, sir. Incident.
That is the second condition. First condition. That is where I began today's class, my dear friends. Anyone?
So the critical angle should be more than 90 degrees.
No. Did I ever use 90 degrees with critical angle? I've
I
already.
greater than C, sir.
That is condition number two, my dear friends. Condition number one. That is how I
So
start.
both the angle of incidence and angle of reflection should be in same medium.
No. Hey, Ram. The light must travel from.
Incident on the denser medium.
Yeah. See. Light must move from.
Incident on interface of the denser medium.
The light must move from denser to rarer medium. That is the first condition, my dear friend. It is not possible for any angle if the light is moving from rarer to denser medium. Do we understand this? It is only possible. See, simple fact. It is only possible when light moves from denser to rarer. This is how I started the class. Yes or no? No, yes.
Yes, sir.
Yes, sir.
Okay. Please don't disappoint me with the second condition. What is the second condition?
I is greater than C.
That is clear. The angle of incidence must be greater than critical angle. But remember, that is not the first condition. The first condition is definitely light must travel from denser to the rarer medium. Do we understand this? Yes or no? No, yes.
Yes,
sir.
sir. Understood.
Paka?
Yes, sir.
Can I now give you a question, my dear friends?
Yes, sir.
Everyone is ready?
Yes, sir.
Let's see if you can give me the answer for this one, my dear friends. I have faith that you can answer this. I'll call this question number one for you guys. Find the maximum angle that can be made in glass medium if a ray is refracted from glass to vacuum. Refractive index of glass is 1.5 and you have 1 minute to solve this. Yes, my dear friends, do you have an answer? Find a max angle that can be made in glass of medium. Glass medium. Refractive index is 1.3. Light is refracted from glass, denser to vacuum, rarer. Yes, my dear friends. So which angle are they asking us, bacha?
Critical angle.
Find it out. How will you find it out, bacha?
Sir,
Yes, tell me. Sine of C is equal to
is equals to 1 sine 90.
1 by mu. Yes or no? That's the formula.
Yes, sir.
Mu is given as 1.5. That is 3 by 2. 1 divided by
The
3
sine
by
minus
2.
Sine
1, 2
inverse
by
2 by
3.
3.
2 by 3. So C becomes sine
Sine
inverse.
inverse 2 by 3.
That is the answer. Why it was taking you so long to give me the answer, bacha? Confused?
No, sir.
Then, sir, what, sir? Did not want to give answer, sir. That is not good, na, sir.
Did,
You
sir.
know the answer, give, na, sir. See, if you're not giving me the answer, you will not even give me free treatment when you become doctors. Answer is what I'm teaching you and you are giving me free treatment. I was thinking that I'll get free treatments when you become doctors, MBBS and MDs. I will come to you and you will treat me for free. You're not giving me answer for free. How will you treat me for free? You broken my heart, my dear friend. Shameful day for me. Anyways, you can make it better if you can solve this question. Comes the second one. And remember, whenever total internal reflection happens, the light gets reflected back, and angle of incidence and angle of reflection become same. Do we understand this?
Yes, sir.
Yes, sir.
Then comes the second question, sir, and I hope future doctors will be able to solve this because this total internal reflection is a big part of your medicinal equipments. You might have seen one equipment they put inside your body and it sees everything inside your body. Have you seen that equipment? Do you know what it is called? Optical fiber. Seen that? They put a rod like thing, they put a pipe like thing inside your mouth and it sees everything inside your body. That is total internal reflection, my dear friend. So let us hope that you give me the answer for this one.
Sir, I think I got the answer.
Sir,
Well, thinking is believing. Yes. Yes, bacha.
Sir,
sine inverse root 3 by 4.
root 3 by 4.
Sine inverse root 3 by 4. That is correct. Well done, my dear friends. I'm pretty happy that you got the answer. The refractive index is given as 2. So first of all, let us find out what is the angle of incidence. Let us take step by step. So I can find out first the value of sine C. Sine C is 1 by mu. Yes or no?
Yes, sir.
So
Yes,
it is
sir.
1 by 2. That implies my critical angle will be sine inverse of half. So critical angle becomes 30 degrees.
30.
Yes or no?
Yes, sir.
So
I
I
is equals
becomes
to
60.
2C. 60.
I becomes equal to 60 degree. Now remember that critical angle is 30, but my angle of incidence is 60 degrees. Will total internal reflection take place? Yes or no?
Yes, sir.
Abhidam, will it take place? Yes or no?
No, sir, it will not take place. Total
It
internal
will not
reflection.
take place, though.
Why? I
Because
is greater than critical angle?
sir, instant ray is in rarer medium, no, sir.
Yeah, that is the point. The light is in the rarer medium. From rarer to denser, whatever happens, TIR cannot take place. So now I know the angle of incidence. I know the refractive index. I now can calculate the angle of reflection by our own
Yes, sir.
Snell's law that we have used so many times. This is the Guru Mantra for this refraction, Snell's law. What has happened? My pen has disappeared. Oops. Screen sharing has been closed. Why this happens, God only knows. Don't worry, God always helps those who help themselves. So I've helped myself and I brought the screen now. Again, see, and SN. Yes, I was writing Snell's law. So, Snell's law. So I again apply the same gentleman Snell's law here. How do I apply Snell's law? The light is in the rarer medium. Refractive index is 1 here, multiplied by sine of 60. Yes or no? Do we understand this? This is the
Yes, sir.
easiest way to remember Snell's law. I always get confused. Mu1, mu2, mu3, mu4. I into mu, sine I into mu. Easiest way to remember this. So 1 into sine of 60, that will be equal to mu. Mu is given as 2. Yes or no, my dear friends?
Yes, sir.
Multiplied
Yes, sir.
by sine of r. Now the red part is very simple. 1 is okay. Sine of 60 is root 3 by 2. 1, 2 also comes from the other side. So root 3 by 4 becomes my sine of r. That implies my r, the angle of refraction, becomes sine inverse root 3 by 4. That was the correct answer that I was looking for. And I also wanted to check whether you understand that the light is going from the rarer medium to the denser medium. So no matter what happens, TIR cannot take place. Am I clear, my dear friends? Yes or no? No, yes.
Yes,
Yes,
sir.
sir.
Can I present one more question to you?
Yes, sir. One more question.
Okay, so there comes the next question, and I will make this question. What has happened? I don't know what has happened here. I just put something and this thing happened. What? Oops. Funny things happen in life. And oops, I had created some extraordinary pages. All these laptop shortcuts, they are so clumsy. I just press a button and strange things happen. Okay, so this is a question that I'm going to frame for you. I've seen this question in one of the exams. So That is what you have to find out. Find critical angle C for glass water interface. For glass water surface, refractive index of glass is 3/2. Refractive index of water is 4/3. Which is the denser medium? Which is the rarer medium?
Sir,
Yes, sir. Which is the denser medium? Which is the rarer medium?
sir,
Glass is
water is denser, glass is rarer.
glass is denser.
The
Glass is
glass should be
denser.
denser, right?
Arey
3/2 is
re, arey
greater than
re,
water.
arey re, arey re. Okay. Glass is denser and water is rarer. Okay. Can I have the answer, please?
Yes, sir.
So I can just put the formula straight away. Sin C will be equal to mu R. Yes or no?
Yes, sir.
Yes, sir.
Mu R divided by mu D, 4/3 divided by 3/2, and your answer I think would be 8/9. If you get 9/8, it is definitely wrong. Yes or no? So the answer has to be 8/9. That is one way of remembering it, but that is not the way you should remember it. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
That is it that you must remember about total internal reflection. Now comes some phenomena that is observed because of TIR. These have come in your exams. Why this happens, why this does not happen. So just note them down. What are the phenomena which happen because of TIR? And this is the first phenomena. What is very once you become doctors and MDs, you will earn a lot of money, and then you will buy this obviously for your loved ones and dear ones. One of the most normally things which are rarer, they are very costly. But diamond is very common. It is not costly because it is rarer. What makes a diamond costly?
Sir, it's beauty.
And what gives diamond its beauty, my dear friend?
Sir, the way it sparkles when light shines on it.
And why does light shine on it?
Sir, because of its reflection.
Because of total internal reflection, my dear friend. TIR, diamond cutting is a very, very big business. This bigger diamond may be only 5 rupees, but only this diamond could be worth lakhs and crores. Why? Because of the cutting that it gets. Because of this diamond cutting, the refractive index of diamond is very high. Therefore, the critical angle is low, 24. If you cut the diamond in a very good fashion, the whatever light gets into it, it just keeps on internally reflecting, and that is why the diamond sparkles. The sparkling of diamond is due to TIR, and that makes it costly. Cutting of a diamond is therefore the biggest business in Surat. I think Surat is the diamond capital of India. There was a point in time where almost 70, 80 or 90% of diamonds were taken from India. And that is why whenever you see a diamond merchant, he will always look like this. Okay. He looks at the angles on which the diamond is cut. Do we understand this? So that is one phenomena where you have TIR coming in. So the question will be like that. Sparking of diamond is due to what? Or they will give you which phenomena uses TIR. So they will give you 4 options. One of these options would be sparkling of diamond. Do we understand this? Yes or no? No, yes. You don't have to write the entire thing. You just have to write sparkling of diamond. Got it?
Yes, sir.
Then the next thing, as I told you, is optical fiber. You might have internet connection at your homes, and they say this is optical fiber connection. Optical fiber, because of total internal reflection, the light can move from one end to other end. Signals can go from one end to other at a very fast speed, at the speed of light. Optical fiber, and this is what use doctors also, surgeons also use. They have this device where they put you inside their mouth, and they see what is there inside your body. Yes or no? Optical fibers are using, you just need to write optical fibers. They use optical fibers, use the phenomena of TIR. Will you remember this? Yes or no? No, yes.
Sir.
Yes, bacha?
Yes, sir.
You just have to
Yes, sir.
write sparkling of diamond, optical fiber, nothing else. I've seen straight away question coming from this part. Then the third phenomena, you have noted this down? Third phenomena is mirage and looming. Mirage happens in deserts where you see images of object on the hot desert sand. You might have heard about mirage. Yes or no? And it looks like water. Yes or no? No, yes. The opposite of mirage is looming, that
Yes, sir.
we see in polar regions where things on ground appear in the sky. So many a time they see all these UFOs, mostly in the polar regions. They might be just ship moving on water, and they see it in the air, and that is why it disappears all of a sudden. Do we understand this? Yes or no? No, yes.
Yes, sir.
Mirage and looming are the two phenomena opposite of each other. Mirages happen on hot desert sand, whereas looming happens in the polar regions. This is all that we need to know about TIR, total internal reflection. When does total internal reflection happen? Yes, question. When does TIR happen? Arey, say, I'm asking you a question.
Mirage and looming.
Arey, when does TIR happen? When does TIR happen? Basic thing you have forgotten. When light travels from
Denser to rarer.
and
I is greater than C.
what is critical angle?
Critical angle.
Is the angle of incidence for which the angle of refraction is 90 degrees. That is what we have done in today's class. In the next class, we'll be going ahead and doing the last part of this plane surfaces, and that is prism. We'll be starting and trying to wind up prism in 1 or 2 classes. That's it for today's class, and I'll see you in the next class. If you have any doubts, please come up to me. Otherwise, go home, take care, and you have had a lot of festival vacations, and there is no time for you to enjoy right now. I hope you understand this, and I hope that I see more of you in the class in the next class. Take care. Have a nice day.
Bye, sir.
Bye, beta.